This is CSE 455, Software Engineering, the 29th of April. It's a Wednesday. First, let me talk about the deadlines for the coming weeks. Um, I have received SRSs and I am reviewing them right now and will return to you my comments via Slack on our communication system, and there'll be a chance to revise your SRS um, to submit by uh, Sunday. That will be the submission of the revised SRS. And for SQAP, uh, I gave the document SQAP and sample last uh, last lecture, and also or last week. I'm sorry. And SPMP, I started talking about SPMP, the Software Project Management Plan, which will be due also on the 3rd of May. Now, remember, the SQAP is the responsibility of the QA teams only. The SPMP is the responsibility of the project manager and assistant project managers only. Okay? So they're the ones planning. The software project management plan is concerned with the planning of what are the milestones and work units that needs to be done in the next uh, 3 weeks or 4 weeks, including this week, uh, where we deliver the first iteration on the 7th week. Okay. And the SQAP is preparing for the test cases that they will try on your first iteration to see if you pass or fail their QA testing. All right? There will be a chance to revise SQAP and SPMP, and that will be due on the 10th of May. That's also a Sunday. So I will review your SQAPs and the SPMPs and give you a chance to revise it and um, submit the revised SQAP and SPMP on the 10th of May. Now, these are upcoming. The upcoming document, this is the design delivery. That would be a software architecture and design. Again, this is the responsibility of the project manager and assistant project manager and any software engineer interested in learning design. So the management team, consisting of the project manager and assistant project manager, can ask help from the software engineers if they are interested in being involved in the software architecture and design. Remember, the software architect is the highest paid personnel in software development companies because they are the ones that decide on what is the structure or what are the components of the software that you are building. Without them, coding cannot work, cannot start. And so we need to identify the different components, the different modules that you will need to build the software. All right. And that will be an ongoing activity which will be due from 11 to 15 of May. And for that particular week, I expect the SAD to be due on the Friday of that particular week, the 15th of May. This one here. Okay. All right. Oops, I pressed the um, wrong button. And so delivery of the first iteration and QA testing of the first iteration will happen on the week of the 18th to the 22nd of May. All right, so that will be our seventh week, the seventh week of our existence. And during that particular week, we are testing whether the QA is going to pass or fail the iteration that you are submitting. So that is our um, uh, schedule for the next um, 3 weeks, 4 weeks, including this week. Okay? All right. So we uh, proceed to the SPMP. All right. Now we talk about the outline of the SPMP, and now let's look at a sample PSP SPMP that I selected, and this is for the Coyote Quest. Okay, the Coyote Quest software project management plan. So here are the project manager. As you can see, the project manager has a dual role. He is a project manager and at the same time software engineer. Same thing with the assistant project manager. Also doubles as a software engineer. Now recognize his name? Nicolas Perez. Okay, so he worked on the Coyote Quest last spring 2019. Okay, they didn't put the date here, but he was involved as an assistant project manager and the different software engineers. But remember, the the personnel that is um, that is responsible for writing the software project management plan are the PM and the APM. Okay. All right. Here is the overview. I mean the contents of the report, and we follow the IEEE IEEE format. Okay. So let's look at the overview. So the project summary is just an introduction of what is the project being undertaken here, the purpose, scope, and objectives. So this is details regarding the development plan and the development cycle, and you can actually include here the the purpose of the first prototype and the second prototype. Okay, what is the purpose of this document? To produce those two prototypes, and uh, the um, the purpose, of course, is the organization and project management. Okay, so here are assumptions and constraints that they have listed, and what are the project deliverables. So they um, um, uh, specified that it will be publishable on the Google Play, and the documents that we have are mentioned here that needs to be delivered. Okay. Schedule, it's not mentioned here, but I would recommend that you talk about your schedule. Your schedule is fourth to the seventh week is the delivery of the first iteration. That's the development time for the delivery of the first iteration. And from 7 to finals week is the development time for the second iteration. That is the schedule. Okay, so you give kind of a date to say when is the delivery of the first iteration, and that is 11 to 18, and the delivery of the second iteration is finals day. And I believe uh, finals day is finals day is on uh, June 10, the 10th of June. That's our finals day. Okay? Budget, we don't have a budget, but if there is one, you have to put the total amount that the whole project will will need. All right. Evolution of the plan and the evolution of the plan. The team met with the client on this date, discuss expectations, and what is if there is existing code, and so the plan is based on what are the features or functions that will be added or improved, or what are the things that the client wants for this iteration. Okay, references. You have references that were used. The Android Studio development documentation, the IEEE SRS was cited, and a previous SPMP that was used before. They use it as the reference here. Okay. Then the usual definitions of terms, and this time these definitions of terms are limited to the management. Like me, I am the CEO of the software company. But if there is a supervisor, or there is a vice president for this particular project, you will need to define all the terms that you are using. Okay, client doesn't see the SPMP. Okay, all they are interested in is the requirements and um, uh, the testing of the iteration that you will produce. Okay, so this document SPMP is only for the software development teams who will be responsible for the production development. Okay, these are external interfaces. So you see here that the uh, uh, that the assistant project manager and the uh, project manager communicates with me externally. The QA team communicates with the project manager right here. And the software engineering team as a whole is um, communicates with the client. I don't know if that is good. You want although probably the interaction here is a consulting. or tutorials that the team needs. Okay, but this is externally how the team interacts with the external entities. Me, the QA team, and the client consultant. Okay, how do they communicate with the team? Okay, and here is defined how they communicate with each other there. Now, the internal structure only concerns the project manager, assistant project manager, and the software engineers making up the whole team. Okay, as you can see here, everybody communicates. All the software engineers can communicate with the management team. The management team communicates with each other, but I don't see communication among software engineers. I think they should, okay? Because if they are integrating modules that are produced by the software engineers, they must communicate to integrate their um, modules, components. Now, the important thing about this internal structure are the roles and responsibilities. Okay? So the project manager has this responsibility. The assistant project manager is responsible for this. The software engineers are responsible for this particular task. Okay. Now, I want the specific task, not ambiguous tasks, assigned to each software engineers. I also encourage that the management team must be involved in development. Okay, the requirement of a good project manager or team lead is that they are familiar or they are actually also participating in the development. The management team cannot be detached from the development because if the uh, software engineers runs into trouble, uh, the management team, the project manager and assistant project manager should be able to help in the uh, development process. They cannot say, go back and work some more. That is not a very good help to the team, but you try to help your software engineers by understanding what is the issue and suggesting ways of how to resolve the issue. Okay, you cannot be detached from the development team. That's a sign of good leadership. Okay, you cannot just be manager only or developer only. You need both. Okay, as a developer, you may be a poor manager and you don't know how to motivate your team to uh, to do the job more than what you ask them, and and also if you are you only know management, you cannot help the team um, develop without you participating in the development. So you cannot just be 100% management or 100% developer. You must be both. Okay? I would say 50-50. You are a manager and a developer at the same time. Okay? So don't get into your head just because you are manager, you are not involved in development. You are involved in development. Okay? And the only difference is that you are responsible for managing the whole team. Okay? Uh, where and what are the things you are supposed to do, and based on your schedule, have a plan on how to deliver your uh, first and second iteration. Okay, so the estimation plan here is focusing on uh, the client specification, studying and researching existing code, keeping tab on progress, and create guidelines for working prototypes 1 and 2, including uh, deadlines. Okay, and the estimation plan here actually refers to the delivery of the first and second iteration. Now, staffing, remember that on the first day of the class, we asked you to fill up a survey skill. So mention that here, the staffing plan. How did we arrive at the different teams and assignment of projects? We did that through a survey skill um, uh, form that everybody should fill up, and we have an algorithm to determine which is the best project you will join. Okay, and we also rank you from most qualified to the least qualified. Okay, and the first choice in the list, since you are the most qualified, you are eligible to be the project manager, and the second choice is the assistant project manager. Okay, that's how we arrive at the staffing plan. Okay, resource acquisition plan. Um, you have been requesting MacBooks and Android phones. So for the team affected by this resource acquisition, you acquire it through me. I issue you loans of these computers and how you acquire them. Okay, of course it's a loan. All right. Uh, a staffing training plan. Remember, um, in here you should mention the 3-week tutorials that we gave you. So describe that training plan that we did. We had a training of Bitbucket, Slack, and many other supporting tools on the first week. And then the second week, we talk about Android and iOS development. And on the third week, we have the asynchronous Android and iOS development. So describe those or mention that in the project staff training plan. Okay, so I don't agree with this paragraph here. You should mention those um, training uh, lessons that we gave you. Okay, so what are the work plans? Okay, here they identify work units as the prototype 1, prototype 2, and documentation. Now, in addition to this, I want you to identify work activities or work units such as design. Not only the prototype, but also the designs, software designs that go into the work units. Of course, you don't come up with a prototype immediately. The prototype or iteration number 1 consists of modules. So you must identify the major modules that need to be done first, or need to be improved, or need to be recoded as your work activities. And those code for the modules or the components need to be mentioned in your work units. Okay, here is the schedule allocation, and I said I want exact month dates and what is needed to be submitted. So here are the units of work units that needs to be um, developed, but I want to see this schedule allocation to use the Gantt chart. G as in golf, A as in alpha, N as in November, T as in tango, T as in tango. Gantt chart. I will show you, or I will remind you of an example Gantt chart that we discussed in chapter 3. But you can look for the tool that draws a Gantt chart. That will be useful for you. Okay? So here are the schedule allocation, but I have a comment about this schedule allocation that it should be in a graphics form rather than a listing of the dates. Okay. Resource allocation. Of course, during that time we have Jack Brown as our lab, but now we are not able to access those workstations in Jack Brown. So we rely on our own personal computers for to work on the project. Okay, you have a budget allocation. There is none. Okay, but if there is one, this is the place where you estimate based on the time. Here is the date that you're going to begin work, April 15 up to June 14. What is the budget that you need? What will you need to uh, pay as salaries to your software developers? As you know, 99.9% of the budget are salaries of the software developers, software engineers, project managers, assistant project managers, QA, engineers, and so on and so forth. Okay? So here in section 5.3, you will have a statement on how do you control requirements. So as I have mentioned, what if the client changed requirements? What is your protocol on how to do that? Or add more requirements. How are you going to handle that? As there is a saying, the customer or the client is always right. And so there should be some kind of a compromise on how to satisfy the client. Schedule. If during the middle of our development you realize you cannot meet your deadline, so how do we handle that? How do we change the schedule from a specific deadline to another deadline? And software development is very very likely to not finish on time, and that is true of many big software projects that we have, like the Microsoft Windows. Okay, budget control. If we need more money, how are we going to? Of course, if the schedule change, the budget will change as well. So, what are your justification of why budget should be changed? Quality control plan. Our measure of the quality of our software is through the number of faults that you discover per 1,000 lines of code. Now remember, the software, the development teams are doing unit testing, integration testing, system testing. They should gather all the faults they found during those testing. Divide that by the total number of codes you have, okay, and normalize it to 1,000 lines of code. And the number that will come out, the density of faults per 1,000 lines of code, is the quality of your software. And in the detection of error, we can only test for the presence of error. We cannot detect the absence of error. Okay, think about that. If you have a test case and you ferret an error that was done, yeah, you are successful. The error was discovered. But if you have a test case and no error was detected, was it because there was no error, or the error was undetected because of the inappropriate test case you have used? Okay? So we can only test for the presence of error. We cannot test for the absence of error. What we do is try um, selecting the best test case. And if you think that's the best test case with a high probability of detecting an error, then you are successful, but not 100% sure that there are no more errors in your system. Okay? So bear that in mind. So the only thing you can do is try to get the best test case you can think of. And that's my motivation to the QA team. Your your mission is to crash the system. So think of test cases that will crash the system. That's your purpose, to crash your mobile app. Okay. Uh, Although it may sound kind of uh, competitive in nature, and you're trying to put down the development team, but that's your job. The QA team's job is to bring down the software that you produce. Now, if in spite of the effort of the QA team to crash your program, and they fail to detect an error, then you are successful in your testing, but not yet 100% sure that no error exists. Okay, so that's kind of a dilemma that you have to think of. Reporting plan. How do you report to me on a bi-weekly, I would say weekly report of what's going on in your team? So I would require this, reporting your status at the end of every, let's say, Friday or Saturday. Okay, just one paragraph in Slack of what was accomplished the week, and if you are still um, following your schedule on time. Okay, I want to know that, and I will bug you for that brief report of what is the progress of the software development. The metrics collection plan, we're going to measure your productivity. How many lines of code does the team produce per hour? And what is your number of polls per 1,000 lines of code? So I want you to gather metrics on productivity. What is the productivity of the team in terms of lines of code per hour, and the quality metric, which is number of faults per 1,000 lines of code. Okay, so that should be the metrics collection plan. Now, metrics are very, very important to engineers. Without metrics, we cannot measure whether we are accomplishing our goal or we are not. Okay, so metrics, especially productivity, you want to know if we can finish on time, if there is an estimate of the total lines of code that the project will need, and you are keeping track of how many lines of code do you produce per hour, then you can estimate whether you can finish the project or not. But the important thing here is, how do you estimate the total lines of code of your project? That will be another topic in software engineering, and there is a way to estimate the total lines of code that your project will have. Okay? And the quality metrics, you want to guide the team to produce good quality code. Okay, and if the fault is very high, then there must be a way to improve the quality that the quality of code that the team produce. Because if you have so much number of errors per thousand lines of code, you spend a lot of time fixing it. As you know, a fault or an error is hard to debug. You would rather spend that time development rather than debugging. And how do you avoid that? And that's a problem with the management team. How do you avoid uh, committing that error and spend less time in debugging? Okay? All right. So, risk management plan, as I have said, you have to identify things that can go wrong. So, in this example, they talk about development risk here and what can go wrong in the development. So they focus on the development, but that could be another risk is uh, the risk of the complexity of the project. If it is too complex, you are uh, spending more time dealing with the complexity, or if the team is not cooperative, not cooperating, then you have a risk there in management. Okay, so the risk can be divided into the the project itself if it is too complex, and the team if the team is collaborating or the team has uh, enough skills to carry out the development. Okay, so how do you mitigate those risks? How do you handle complexity of the software that you are developing, and how do you mitigate the lack of skills of the developers, of your software engineers? Okay, a closeout plan is very important because this is where we collect all software artifacts. Software artifacts consist of SRS, SPMP, SQAP, the software architecture and design, the source code itself, maintenance manual, and other supporting documents and design that make up the entire software artifacts of the project. Now, the uh, the purpose of keeping all these repositories is the software lifecycle. Software lifecycle doesn't end at the delivery of the prototypes. It consists of a cycle that you end with this course, 10 weeks of developing this project. Of course, we are not done yet. After 10 weeks, another team or another set of developers could be interested in continuing the work. But of course, in a software company, it is the purpose of the agile, iterative, and incremental development. They have to move forward towards the completion of the project. The iteration is just a step closer to the finished product. That's what you are aiming for. Okay, so you are doing tiny steps to complete the project through incremental steps, and then at the same time uh, getting closer and closer to the completed project. Okay, now the process model that was used by this team is Scrum. So they have a 7-week sprint, and the 7-week sprint here consists of training, planning with the client, and then they go into implementation, testing, repeat cycle for QA, and then finally final delivery. Well, this final delivery is of course the delivery of the first iteration. So this cycle here is for 7 weeks. but it should also include um, the finals, the finals delivery, which is another 3 weeks of the iteration. So this is what they adopted, and I want every team to adopt a process model that the team should adopt and carry out in your team. Okay, that would be a requirement that the team should be doing. So here, the Scrum model is defined, and I want a specific responsibility on who is going to be involved in the Scrum model. Okay. Methods, tools, and techniques. I would include here DIA, which is a tool that we use in drawing, UML diagrams, and Gantt, the Gantt chart, which is you're going to use to specify scheduling. Okay. Um, Infrastructure plan, if you have any, and the product acceptance plan. Of course, the client will be kept in the loop during its development. Okay. Other supporting process documents. Okay, we had the bit bucket. I want you to say more here in the configuration management plan. What is the purpose and what are you keeping in the bit bucket? As I have said, all our software artifacts must be stored in the bit bucket, and they should be left there for the next team to continue the work. Okay. Verification and validation plan refers to testing. Okay. So unit testing, integration testing, system testing should be part of the verification and validation plan. So each team should practice verification and validation of their code that they produce. Okay. Documentation plan, you have many documents. Part of them are the SRS, SPMP, and I want to include the maintenance manual and the software architecture and design document should be included in the documentation plan. Here, you talk about the QA team. What is their purpose? The purpose of the QA team is to test your iteration. Once you deliver your iteration, they should be tested by the QA team. And the QA team will give a copy to the client for the client to actually test it or play with it and give you further requirements. Okay. Reviews and audits, they will do reviews and audit of your software process. Are you are you following the coding standard? Are you using the repository correctly? And they will review if you're doing verification and validation plan. That is unit testing, integration testing, and system testing. They will review that you are following it. Right? Problem resolution. If we have a problem, how do we resolve it? What are the things that could happen? And there is the problem could arise from the complexity of the project, or it could concern the management of the development teams. As you know, there is always a problem with one or two software engineers who are not doing their job. And here, every software engineer should be doing their job, because the grade that they get will be a team grade. And if one is not working, or several are not working, they don't deserve that grade. Okay, so I need to know that. How do you motivate every member of your team to do their task and responsibility? And just like in a software company, if you are not doing your job, you can be fired from your team. Okay? And so, as CEO, I have that power. Okay? Just letting you know. Subcontractor, we don't have such a contractor. We're not outsourcing our software unless you pay other students from another class to do your work. That will be an outsourcing, but of course yeah, that is cheating. You cannot ask somebody to do the work for you. Okay. Unless you have a team in China who can do it for you, then good luck. Okay. All right. China or other places like what Kazakhstan or India or any other place. Iceland. I have heard Iceland to have very good software engineers. Okay. Now, the last item in the software project management plan is the process improvement. We are never satisfied with our process. There is always room for improvement. So I'd like you to recommend and right here the uh, the improvement to your software process and using a process improvement plan, you could be better in the next iteration. The thing is, we have problems now, but if we keep improving our process, the next iteration will be better. So that's our aim here, not to find faults, but to find improvements in our software process. So the next iteration will be better produced and better managed. Okay? All right. My lecture on uh, software project management plan, let me refer you to the uh, to chapter 3 here, chapter 3. Where you have a diagram for work units. Okay, work units. All right. Here in the work units, the example in our book is a implementation or development of a database subsystem. Okay? Database subsystem, and the work units that is being thought out is that first there is a requirements elicitation, task name right here. Then there is a database subsystem design right here. Then the implementation. Then the database inspection, test plan, and then the testing itself. Okay. So this task name or work units are going to be depicted as a Gantt chart, and they are listed here on the task name. The requirements elicitation takes 5 days. The system design takes another 5 days. The system implementation takes 15 days. The subsystem inspection takes 2 days. the subsystem test plan takes 10 days, and the subsystem testing itself takes 5 days. Now, how are you going to depict that in a Gantt chart? So the Gantt chart tells you the month dates and a bar, horizontal bar, that represents the duration of the task. So you see here, the requirements elicitation takes 5 days. So that's the amount of time that takes for the requirements elicitation. Then after 5 days, you begin the subsystem design. So this is a sequential task. After elicitation, you begin the design. But after the design is done, there are two parallel tasks that you can do. One is the coding or the implementation, and the other one is the test plan. So here, they have the plan of as soon as you start coding, you also start determining test cases. So that is a very nice, or it follows a good methodology that you don't think of test cases until the source code is completely done. It is done at the beginning of coding right here. Okay, since the implementation takes 10 days, the test plan takes 15 days, I'm sorry, the implementation, but the test plan takes only 10 days. So it will finish early, and at that point in time, it will wait for the coding to be done and the inspection to be done. Okay? When the inspection is done, then it begins the actual testing, which takes 5 days. So the project or the prototype will be done on December 25. Okay, so I want you to use Gantt chart in your schedule, and that would be a very good representation of the total time it will take to finish the project. Okay. All right. So let me get out of this and this one too, and we move on to the next slide. Okay. So the next slide is about agile software development. I have mentioned agile software development very often. And here is a website that you can look for what is agile software development. So according to this, the agile software development comprises various approaches to software development. So there's not only one agile software development, but many. And the requirements and the solutions evolve through the collaborative effort of self-organizing and cross-functional teams. So the teams are very flexible in terms of the organization, depending on what the purpose is. Cross-functional, that means every member can actually perform various functions. And the customer or the client, the client and the teams are collaborating very closely. So it's very important that you always involve the client in your development, and always asking if what you are doing is correct, okay, or according to his requirements. Okay, let me tell you about the agile software development principles. There are 12 of them, and remember that the the description of uh, the description of agile software development. It is iterative, it is incremental, and it is evolutionary. Okay, so that is the main description of the agile software methodology. So the uh, most agile development methods, so there are many of them, break the product development work into small increments that minimize the amount of upfront planning and design. Iterations or sprints are short time frames that typically last from 1 to 4 weeks, and each iteration involves a cross-functional team working in all functions: the planning, analysis, design, coding, unit testing, and acceptance testing. Okay, so one iteration lasts only maximum of 4 weeks. All right, and it involves iterations, incremental development, and evolutionary. Okay, so look at the first agile software development principle: customer satisfaction by early and continuous delivery of valuable software. So that's where the client is involved in the team by continuous communication with them of what's going on. Okay, so they're always part of the uh, development by giving you giving you directions whether you are proceeding correctly or not. Welcome changes. So even in the late development. So from the client, since you are evolving incrementally, you are not finishing the product at that particular iteration. The customer always has the right to change requirements. Deliver software frequently in weeks rather than months. Okay, so very short time of development. Close daily cooperation between business people and developers. So you should be, if it is going to be used in a business environment, you should be able to have a close and daily cooperation between the business people and the developers. After all, who will use your software? It is the business company people who are going to use it. Okay. Um, the projects are built around motivated individual who should be trusted. Okay, so the team is committed, and each particular individuals are motivated to actually finish the project. Are you committed? Are you did you buy in into the product? Okay, so you must believe. You must first believe in the product and believe it is useful. Okay, then you'll have the motivation to do your best. Okay, face-to-face conversation is the best form of communication. Okay, this is very hard to accomplish since we are in a lockdown, and that is why my own personal opinion, online teaching of software engineering cannot be done, but we're doing it. So to the best of our ability, we are trying our best to make it happen. All right, but um, the best way to do this is by face-to-face communication. Okay, the working software is the primary measures of progress. So if you finish iteration number 1, that's a good measure of progress. That means we can continue on to the next iteration. If we don't finish the first iteration, then we can't continue. We have to keep working until we finish the first iteration. Okay? The sustainable development are able to maintain a constant pace. So we should not be taking it easy. We must sustain our development. We continue development for until you produce a prototype. Of course, um, we have to follow up with the client whether the 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 latest iteration fulfills his or her requirement. Continuous attention to technical excellence and good design. So that means during the development, you should always be adapting sound technical uh, sound technical um, techniques that we can use and good design. All right. So we'll never rest until we use the latest techniques, the latest methodology to continue the project and also for good design. Simplicity, the art of maximizing the amount of work not done is essential. So we should always choose the simplest way of doing things, and we should be simple in our way of solving problems. Okay, best architectures, requirements, and design emerge from self-organizing team. So in your team should be flexible to adapt to the different requirements. Just like in some of the teams, like the iBox, where we have to organize into two sub teams, one for iOS and one for Android. We need to be able to adjust and organize according to what is needed. And then finally, regularly, the team reflects on how to become more effective and adjust accordingly. So every team member should be flexible to adapt to the new method that we are adapting. Okay, so here are the different approaches to agile software development. Okay, so let's look at the waterfall. The waterfall model looks like this. Okay, it is one of the oldest software development method used, but when it was used, you assume that 100% of the requirements is known at the beginning of the project. So all of this can't begin until you know all the requirements of the client. And once you have all the requirements, you go through design, implementation, verification, and maintenance. But the implementation of all the requirements at the beginning of the software lifecycle could take months or even years. And so what happened is that after several months or several years, you will find the product over here, and it is the wrong product. Okay, because nobody can determine all the requirements at the beginning of the development. There's always questions about what is the requirement. So how is agile methodology applied here? In the requirements, we don't need the whole requirements determined at this particular iteration. All we need is derive from the client some or initial features or functions that the software will have. Not necessarily the entire functions or features that it needs. So you select only a few of the functions that you will implement here, functional and non-functional requirements, and then you go through design, implementation, verification and maintenance to a sprint, let us say 4 weeks. So in 4 weeks' time, you will produce a prototype of first iteration here from which the client can test. And once the client says they are correct and it satisfies his requirements, then you get the next sets of requirements. So that's how the waterfall can be applied to Agile. Sometimes it is called micro waterfall model. All right. So you can adapt that if you like. And here is the famous methodology that you have heard. Scrum is another one. And Scrum has this graphical representation of the Scrum process. Okay, so you have the product backlog. So here are the functions that you have, products that you have in your lineup. And what you do is for each product, you determine, you divide the functions that need to be done. So you can arrange them by priority or by initial set of function that needs to be done, followed by the next set, followed by the next set, and so on and so forth. So for each of these set of functions that you decide you can do in 30 days, so that's 4 weeks, okay, well, a little over 4 weeks, you create, that you start development in 30 days, but every day, 24 hours, you meet. Okay, so it is a constant daily development. You meet daily, and then after 30 days is done, you produce a certain set of function. And you get the feedback from the client. As soon as you do that, you pick up the next set of features, another 30 days, and then you meet daily, and then at the end of that, you increment, you have a working increment of the software. So the software is being built by iterations. And after several of these iterations and incremental development, you produce the complete software. So that's Scrum, okay? And Scrum is very popular in software development of today, okay? The next one I'd like to show you is the XP. It's called Extreme Programming, okay? And Extreme Programming works like this. So all the software engineers are grouped into pairs. So they are pairs, and each there is no team. It is just the team is the pair of software engineers. So at any one point, one is a coder and the other is a observer. The coder codes, while the observer takes note of the code that is being typed, make sure there is no typo and so on, but at the same time prepares test cases to test the code. Okay, so at the end of maybe perhaps seconds of the code being done, the unit test is done to the code. Okay, and also after a certain amount of time, the observer becomes the coder, and the coder becomes the observer. So you exchange position. Okay. Then after hours of work, the pair negotiate in terms of what they have done so far and things that they need to do or improve. Okay. And then they attend a stand-up meeting of other pair programmers. A pair programmers stand-up meeting um, to discuss what they have accomplished and what they have to do to integrate their code together. Then the next step is acceptance test. So after integrating the work of the pair programmers, they do an acceptance test. If the test, if the code is acceptable, okay, and then after weeks or after, the stand-up meeting is after days. The acceptance test is weeks, and then after several months, you have you produce an iteration of the software. So as if the iteration is good, then you continue on to the next iteration of the software, and then you release. And this paradigm is mostly used in the production of video games. As you know, video games are enormous. They're huge programs and needs to be done in an incremental manner. So you can think about if the program like the World of Warcraft, which consists of several worlds, each has to be built, um, the worlds and the characters and the scenery, the game world and everything, the quests and all of that are put together as it is being done. So this is a very nice feature of XP, Extreme Programming, when you have to produce large software that maybe you don't need to maintain. Because once the video game is out there, it's done. The life is over. You don't maintain it. You don't continue. Maybe you can use the same characters, but not the same scenery, not the same world, and not the same gameplay and game mechanics. Okay, so that's how this extreme programming works. Okay, and the criticism, if this is applied to regular software, the criticism is that you only code and you test, and of course you listen to the client or to the game tester. Listen to the game tester, and since you don't need design here, design was added. Okay, and design is actually an afterthought of the after you produce the software. The design is done. It's like reverse engineering your code and keeping that as part of the document. So this is only true if the software has a life cycle. So if it needs to be maintained, then you need the design to maintain the software, or else you'll be dealing with lots and lots of code. Okay, so there are other software uh, agile uh, agile software developments out there. It's up to you to adapt one. So if you adapt one, I want that documentation in SPMP to to specify a specific paradigm and models and methodology that you would like to use. So I want that documented in your SPMP, and put diagrams similar to what you see in this website of what you have decided to use. Okay, so that ends my lecture today, and we'll proceed as planned on delivery of the first iteration by the seventh week. Okay, so be safe and healthy. See you then.